Let's solve a problem on fragmentation. So the given problem is a datagram of 3000 byte, out of which 20 byte is header and 2980 byte is a payload, which is actual data, reached at a router and must be forwarded to the link with MTU of 500 byte. How many fragments will be generated, and also write the MF, which is more fragments offset to for the given data. So visualizing the problem is something like this, where this is the router, which is, and there is a data which is of 3000 byte, and the size of the header is 20 byte, and other remaining, which is the actual data, is 2980 byte, and then it has to forward ahead to a network, and the capacity of this MTU link is 500 byte. Now this 500 byte is divided into two parts, which is 20 byte header and 480 byte of the actual data we want to transmit. Since we can only transfer 500 byte at once and the total data is 3000 byte, we need to fragment the data. To fragment the data, what we have to do is we have to divide the data in different parts of each of 480. So let's do the ceiling of 2980 byte to 480 byte, because this is the actual data and this is the data we can transfer in each frame. So on dividing this and getting the ceiling value, we will get around 7. So this says that we'll have 7 packets to transfer. In this, like, we'll have to make 7 fragmentation to transfer this data. So let us consider those 7 packets as P1, P2, P3, P4, P5, P6 and P7. Now, since it is a datagram, we all know that datagram is something where every packet should have a header, because it is not necessarily that they follow the same path. So each of this packet will have header of 20 plus data of 480 byte. Now this will transfer data of 500, this will transfer data of 500, 500, 500, 500 and 500. Seeing the packet which is P7, we know that the data is only of 2980, and and to transfer only this much amount of data, 480 into 6, which will come 2880. So for the 7th packet to transfer data, only 100 payload is remaining. So on the 7th packet, only 100 payroll will be transferred, so which will be around 120. So this is the number of packets which will be transferring, which is 7, and these are the amount of data which will be transferred, including header and the payload. Now coming to, this is total load. Now coming to more fragment. Now more fragment is nothing but whether there is next packet transferred in the transmission of the data or not. So as we can see, after P1, P2 is transferred, so it will be 1. After P2, P3 is transferred, so it will be 1. After P3, P4 is transferred, so it will be 1. After P4, P5 is transferred, so it will be 1. After P5, P6 is transferred, so it will be 1. After P6, P7 is transferred, so it will be 1. But after P7, nothing is transferred, so it will be 0. So MF is nothing but the if there are packet transferred after current packet. Now the next thing is offset. Now in offset we will discuss how many data bytes are transferred ahead of the packet. For example, for if we see P1, so how many packets were sent before P1, that we will consider in offset. And one more point to remember about offset is that it is divided by 8. So to get better understanding of this, we will go ahead with this. So here it's like before P1 nothing was transferred, so offset will be 0. Before P2 P1 was transferred, so the actual data which was transferred through P1 was 480, so 480 divided by 8, which will come on 60. So for P2 offset will be 60. This means that 60 into 8 byte of data were transferred before P2. So for moving ahead, let's slide it here. Moving ahead, for P3 it will be 480 of P1 plus 480 of P2 divided by 8, which will come 120. Similarly for P4 it will be 180, for P5 it will be 240, for P6 it will be 300, and for P7 it will be 360. Now just to get a clear understanding of this, for example we are at P7 and this 360 shows that 360 into 8 data were byte data were transferred before the packet P7 was sent. So 360 into 8 and then 24 25 26. So it is 2880. Now this means this much byte of data was transferred before P7, and P7 has transferred 100 bit of data, so it is coming to 2980. If you can see, this is the actual data which we were supposed to send except header, so which is 20 byte. So if we add 20 byte, it comes down to 3000, which was the required amount of data to be sent. So this is how we came to know that for sending a 3000 byte of data through a MTU of 500 byte with the header of 20, we will have to make 7 fragmentation, and in the 7 packet format this will be sent accordingly with the MF and offset this. Thank you.